Hello friends, here it is given that a point moves in a curve such that its tangential and normal acceleration are equal. Prove that the velocity varies as e to the power psi. Also, if the angular velocity of the tangent is constant, find the equation of the curve. So first we see here what is given. So we know that here it is given that a point moves in a curve. A point moves in a curve such that its tangential and normal acceleration are equal. So here given tangential acceleration equal to normal acceleration. This is given here. Tangential acceleration is equal to normal acceleration. One point is given here, tangential acceleration is equal to normal acceleration, and the second is given here, if the angular velocity of tangent is constant. Here it is given that angular velocity of the tangent is constant. We know the tangent makes angle psi with x-axis. So the angular velocity of the tangent is d psi upon angular velocity of tangent. This is equal to d psi upon dt, and here this is given constant. We suppose that this is equal to omega. Here two things is given. One is the tangential acceleration is equal to normal acceleration, and the second one is given angular velocity of tangent, and we know that the tangent makes angle psi with the positive direction of x-axis. So angular velocity of tangent is d psi upon dt, which is given constant. We suppose that this constant angular velocity is omega here. So we can see here, taking first point, tangential acceleration is equal to normal acceleration. Here it is given that tangential acceleration is equal to normal acceleration. We know that the tangential acceleration, formula for the tangential acceleration is v dv upon ds, and the normal acceleration, formula for normal acceleration is v square upon rho, where rho is the radius of curvature. Now we can see here, this square is cancelled by this v, so this can be written as dv upon ds is equal to v upon rho. Also we know that this radius of curvature can be written as ds upon d psi. So 1 upon rho can be written as d psi upon ds. So in this above equation, we put value of 1 upon rho, which is equal to d psi upon ds. So we get here dv upon ds is equal to v multiplied by d psi upon ds. Now on the both sides, this ds is cancelled out. So we can write dv upon v is equal to d psi. We know that this is the first degree differential equation, which is in the variable separable form. So integrate both the sides. Here we integrate this both the sides. Now we integrate this both the sides. We get here integrate both sides, dv upon v is equal to d psi. Integration of 1 upon v with respect to v, this is log of v, and integration of d psi is psi here. We taking constant here log c. Log c is the integration constant here. Now we transform this log c in the left hand side, so this can be log v minus log c is equal to psi. So we use formula of log v minus log c can be written as log v divided by c is equal to psi. Now this can be written as V upon C is equal to e to the power psi. So V is equal to C e to the power psi. Suppose this equation is 1. Now here V is equal to C e to the power psi. This can be also written as, when we delete this 0 equal to sign and C, we can write this V proportional to e to the power psi. In this question it is given that we have to prove that the velocity varies as e to the power psi. So from this equation we can see here velocity varies as the e to the power psi. Here we can see velocity varies as e to the power psi. Now the second one is prove here, find the equation of the curve. Now we have to prove here equation of the curve. So for proving equation of curve, for proving equation of curve, we take here equation 1, V is equal to C to the power psi. Here we know that V is the velocity. This can be written as ds upon dt also. C e to the power psi. V is the, here V is the tangential velocity. This can be written as ds upon dt. Now this ds upon dt can be also written as ds upon d psi multiplied by d psi by dt is equal to C e to the power psi. Here we multiply d psi in the numerator and denominator. Now this d psi upon dt, we know that this is the angular velocity of tangent. This is the angular velocity of tangent. And in above we suppose this angular velocity is omega, because in this question it is given that the angular velocity of the tangent is constant. So we put here constant omega. So ds upon d psi multiplied by omega is equal to C e to the power psi. Now this can be written as omega, this can be written as ds is equal to C upon omega e to the power psi and d psi. We know that C is constant and omega is also constant, so C upon omega is also constant. So we replace this C upon omega by A is constant here, capital A is constant here. So ds is equal to A e to the power psi d psi. We know that this is first order, first degree differential equation in variable separable form. So we integrate this, integrate both sides. So we get ds is equal to integration of A e to the power psi d psi. Here we can see that this is the first order, first degree differential equation. So we integrate this, and integration of ds is s here, and A is constant here, and integration of e to the power psi, we taking other constant, integration constant, this is b here. So we can see here this is the relation between s and psi. S is the arc length and psi is the angle made by the tangent with the positive direction of x-axis. So this represents equation of the curve. This is equation of curve. Thank you.